Yeah, thank you. Let me share my screen. So can everyone see my screen clearly?
Yeah, it's
Yeah.
perfectly fine.
Okay. So thank you so much everyone for attending, and I'm so excited here to be at the Data Science Dojo. Um, today's topic is my most recent work on RAFT, which is adapting language model to a domain-specific RAG. And here's a logo of me as a or it's a monkey studying the textbook. It reminds me of what I was doing during my undergrad years, which is studying for the final book exams. And that's a very great analogy I'll be putting up today on how we can actually use and train LMs or prepare them for an open book exam, but you specifically know the domain of the open book exam in advance, like when we are taking a course in the college. So this is my email address, and feel free to contact me afterwards, or if you have any questions or potential interest in the project. As introduced, I'm affiliated to the Berkeley AI Research Lab, and also this is joint. This work has been published as in Berkeley, but we have a couple of very interesting blog posts and collaborations with Microsoft and Meta to enable wider adoption of the project. So I would also encourage everyone to check out our blog post. And also there's a very like well-written Microsoft blog post that has been read by like 70,000 people up to now. So very brief intro of me. I'm a PhD. I'm PhD final year PhD student at Berkeley. I am advised by Joey Gonzalez, but I also worked very closely with Peter Beal and Sergey Levin, which is from the Berkeley AI Research Lab. And my recent focus is on how to like teach language model to behave as agents. So as a couple of very highlighting projects I worked on. The first one is Gorilla, which is I leading the project. Gorilla is the first project in the academia and also in the industry from last year who is delivering the concept of teaching language models to use tools, to use APIs. This basically designs the entire interface of how language model could interact with your applications, could interact with your laptops. We received tons of reaction and likes on Twitter and also on like Hacker News. Gorilla now has been deployed and used by a lot of companies like Salesforce. We know some Apple people, the recent Apple um, like the WWDC, their model also used the Gorilla as an internal training technique. Also, Gorilla has been used by NVIDIA, etc. A lot of companies really like the project and the concept of how to teach language model to use tools and how to enable them to interact with you. And another project is RAFT RM, which I'm going to talk about today. This is basically says how to adapt your language model to the RAG settings. I wouldn't introduce this project too much because my entire talk is about this. But this project has been also widely recognized and appreciated. Another project I was doing in Berkeley is called this Live Code Bench, which I was building a lively benchmark for coding scenarios of language models that you can go through time to see which model might have some of the contamination in their training dataset. And this is now so far the most popular like coding benchmarks, except for the previous ones like Human Evo, which are really out of date. On Live Code Bench, we know companies like OpenAI, Anthropic, Google, and Meta are really using this to guide their design of the next generation of the language models. Here is a Twitter we published on on the day we launched the benchmark, and Greg, which is who is the president of the OpenAI, retweeted us and saying they found this is a really useful benchmark for them to use. So this is a brief introduction about me and the three highlight projects I've been working on. Now let's dive deep into the topic of RAFT RM, which is a RAG technique. So first, I would want to make summarization and a bold claim here. So RAFT, which indicates of Retriever-Augmented Fine-Tuning, is a training procedure for open book question answering, aka RAG. I would say if you're doing RAG, you should do RAFT because RAFT it's a very simple technique that can enable you to fine-tune your language model to be performing much better than in the open book domain question answering settings. So first, let me trying to draw some analogy and understand how people are interacting with language models today. So language model as a chatbot is a great interface, and this has been introduced by OpenAI since like the December of 2022. When the ChatGPT launches, people are really found it's amazing. So here is a very typical chatting history or interaction you will be doing with the ChatGPT or with any other language model you have in your mind. So you would typically, as a user, ask like, "How are you doing?" And the model would be answering you like, "I'm feeling pretty good, and how can I help you today?" You would want to say, "I want to travel to Hawaii. Could you help me make a plan?" Because I am not very familiar with Hawaii. What's a good food there? What's the weather there? What should I go for tourist? And the model would say, "Sure, I'm very happy to help. Let me actually make you a plan for Hawaii." So in these scenarios, um, the language model are answering your question and can help you out with these specific tasks really well. So here's another question, like you can interact with the language models. So this question is really simple because it is where is the capital of California? And people language model answer you, this is Sacramento. So we call this in-domain knowledge because this kind of knowledge is within language models training data. What do we mean by training data? It's basically like all the web script data. Like for example, in this case, the capital of California should have been answered a lot by the Wikipedia data and a lot of other textbooks, which are publicly available online. And we know for sure that the language model is using those sources to train themselves in the pre-training phase. So that's why the language model can answer you this question without any reference, because it has been trained to remember and to memorize this piece of information. And this information is what we call in the training domain and within the training data of the language model. So the language model supposed to read the Wikipedia in their training time and memorize where is the capital of California. So at the test time, it won't have to reference to any books. It can answer you the question. It's the capital of California is Sacramento. But what about this case? In this case, we call it's out of domain knowledge. For example, here I'm presenting or I'm asking the language model one question, which is help me to find the time of the sky retreat 2022. So why this is out of domain? Because this specific event of a Sky Retreat, which is our lab retreat at UC Berkeley, and we invite all the sponsors, we invite all the industry leaders, and present them with our research and get their feedbacks. But this specific event happens in 2024, and we know the GPT or the ChatGPT is trained until 2022 December. So there's no way that ChatGPT would know the schedule of Sky Retreat 2024 because this is very timely information. This has happened after we train the model. So the model in their training data, imagine you don't know this, you don't memorize, you have no source of this. And of course, you cannot answer this question. And the model will now tell you, I don't have any knowledge, but only until 2023 sometime. That's a range of the time horizon I can answer your question. Your information is very out of date. It is like a very refresh. It's very timely. So it's considered out of domain of my knowledge that I cannot help you with. But this is what we call the out of domain knowledge of the language models. But why this is important? Because a lot of the real world and practical applications, you would require the model to answer this question. For example, like you want to find the timely news, you want to know what's happened yesterday in the world. You would want to know actually the model reading the New York Times. You want to know something happened in the New York Times very recently. You want to know the stock price of the NVIDIA or Meta today. This is one scenario. And another scenario is you have your personal data, which is like you have your personal documentations, you have your personal writings. You may have some, if you're an enterprise, you may have some enterprise specific data, which for NVIDIA, that might be the chip design docs. For Meta, that might be some of the internal like social media design docs. And what if you want a model to help you answer that question? Because that's the most relevant information. That's the most relevant part to your daily piece of the work. And you want your language model to answer that question. And with this paradigm, your language model doesn't know anything about those documentations. It cannot help you. And by the way, I'll be taking questions at the end of the talk. I think the talk should be roughly around 40 to 45 minutes, so we have plenty of time to do the question answering afterwards. So let's get back to this. I think these are the two categories of the knowledge that is we want to extract from language models in domain and out of domain. So since out of domain is really important, people develop a very clever technique called RAG to deal with this situation. RAG stands for Retriever-Augmented Generation. This is specifically designed for questions that are outside of the language model's training data. So suppose I'm still asking the same question, but at this time, I can do a little bit of the retriever, or another word is like database search or Google search. And this time I found a couple of docs, which is maybe the first two are the Google index websites. And the third one is actually the Sky Retreat agenda, which we also publicly put online. And this time we put all of this context to the model. We're saying here is the question I'm answering. Here is a couple of referencing documents that you can use to answer my question. So these docs are usually not presented in the language model's training data. It's what we presented to the model. Suppose we do, let's say, Google search afterwards. So we call this a retriever augmented context, which contains both question and also the retrieved context. Now we put all of this into the language model. So the model now knows what's the date, what's the potential date of the Sky Retreat. So it will answer you the question saying, basically, according to the search results, Sky Retreat is January 8th of 2024. The model now knows this piece of information comparing to, let's say the previous one is I don't have any knowledge until 23. Now the model knows this answer because you presented it with an augmented context that says the model can now both refer to its own knowledge and also can refer to your provided context, which is the Sky Retreat agenda. Now the model can read from it and can extract information from it. So this is a paper originally like RAG is from academia research, and very surprisingly, or not very surprisingly, but it has a relatively long history. 4 years ago, 4 years ago at Meta AI, at the NeurIPS, which is conference of a top tier machine learning academia conference, 2020, people are starting to exploring these ideas. And now this paper are having a wide adoption and wide citations. Basically, people appreciate this work a lot. It has 2,000 more citations. So this continues like the RAG work has a very strong academic background. And how do we do RAG a little bit more detailed? From this paper, and which is their origin, is like this. So people would, so if we ignore this is the screenshot I got from the paper, and we can actually ignore the short like caption or the long caption under the figure here. But most importantly, how people implement RAG is basically from questions to retrieve the relevant documents or to search the relevant documents and then putting them together to the language model. Finally, you ask language model to find the answer. For example, in this figure, you may have the question define a middle year, and then you may have other questions, and then you would go into the database. Like basically think of this middle block as a database, and then you can actually get very relevant documentations from this database. They use a technique called MIPS, which is like the very famous dataset, database documentation tracking technique that can get you the most related, the most relevant documentation according to your question. And usually you would get four or larger than one documentations because imagine if you search a question on Google, usually the very top website maybe cannot answer your question. You need to actually navigate to the first, the second, and third, the fourth to make sure you get the right answer. So here is also the case. When you search in your database, what's the relevant documentation of a specific question, usually the top one results it will give you doesn't contain the information you need. So you would want to expand your search results to, let's say, top 5 or top 10, so that you can have a wider coverage of the documentations that can, with a high probability, contain your contain the answer to your questions. And finally, as we shown before on the Sky Retreat example, this would put into the language model, and the model would help on answering your questions. So this is the traditional RAG pipeline result like presented in 2020. And 4 years after, this paradigm hasn't changed. It's still the same. But RAG 4 years after, what's changed is its adoption. So as the language model becomes more and more powerful, we expect it to be more and more helpful on your daily use cases, which contains a lot of the information that is outside. It's training data that is out of domain. So today, a lot of people are exploring the RAG techniques, which are the same technique, but we have more adoptions today. Here is the Databricks block. Databricks is a very heavy, is a top player of the language model today, and they invest very heavily on the RAG techniques. They're saying like they're putting this blog post on explanation of the RAG, and this is a great documentation. I would also recommend you guys to read. They also train a specific model called the DRPX to specifically optimize for the RAG tasks and documentation reading. And here are a couple of more examples, like a LangChain. They are actually integrating their entire pipeline into do the retriever augmented generation. And of course, the Llama index, which also they use the same picture here, but a lot of the startups and the big companies, like also including Snowflakes, are investing in this technique because this is the actual use case you would want. Sorry, this is covers a lot of the actual use case you have in your daily life. So here is a brief introduction or the brief summarization of the RAG technique, originating from a paper, let's say it's 2020, and up to now it's it's 4 years later people's adoption of this technique. But what is actually RAFT? So how RAFT plays a role in this technique? So let me actually draw an analogy of of the exam I would want to mention briefly previously. So the analogy is as follows. So when we are actually when we are actually taking the exams in the college, there are two forms of exam I can take. One is called the open book exam, as you're seeing here. And another one is a closed book exam, which we also have. It's also a popular form. And the difference between these two exams is like in the open book exam, you can actually refer to any of the online documentations. You can referring to your textbooks. You can actually also search on your laptop to help you find the answer. But in a closed book exam, you are not allowed to reference to any of the external resources. So that's the thing, like taking an analogy to the language model today. So RAG is actually an open book exam setting where you don't study. I'll explain how the study part in slightly later, but the open book exam refers to a setting of RMs that you can reference to external documentations. You can also search on the Google to help you find the results. But the closed book exam is only like the chatbot setting we have seen previously. The model is not allowed to search external documentations. The model is not allowed to search external websites. It can only answer the question based on it only can answer the question based on its own knowledge. Now let's come to the study part. Like what I mean by study is basically the model in prior of the time, they won't know what's the test domain of yours. Thinking about this as an example of how you want to take, how you are taking the exam, open book exam in your college or high school, it's basically you have a scope. You're either tested for physics, or you're tested for math, or you are tested for chemistry. There's a bunch of textbooks of the knowledge that you will be tested on. But in the language model setting currently, you don't know the scope of your exam. Basically, the user can ask you any questions regarding to any domain, regarding to any of the documentations. And by what we mean by study here is basically without knowing the domain, the model wouldn't know in prior what the domain knowledge it should prepare for, what the domain knowledge it should actually extract from itself to answer the question mostly. So this is what we call like what we call study. Basically, back in the high school example or the college example, is you would even though it's an open book exam, you would also read through the textbooks. You would also going through the lecture notes. You also watch the lectures before you entering the open book exam to help you better understand the course material. And that's how you study for the exam. But the language model is not study because it's what they do is just it actually just show up on your exam date. Maybe you're in my college, like maybe let's say you partied too much during the semester and you didn't study for the exam, and then you just showed up on the exam date. And then you are actually trying very hard to find the books, trying to find which chapter and which of the paragraph would help you answer the question. Now you're having a hard time indexing through the books. You have a hard time locating and also reading through and summarizing the knowledge from the book. So if you put the traditional RAG technique on the language model, it's like you take open book exam and you didn't study because the model is not prepared for this specific exam. Now let's say the raft part, how that comes into play. So I think the intuition here behind raft is really simple. It's because if you study, the intuition behind raft is if you study for your exam and you know your course materials in advance, you are going to do better than a student who is not studying for the exam, just walk into the open book exam room, empty-handed, non-study, and he or she is starting to take the exam afterwards. So this comparison is RAFT is a student who studied for the exam, and the GPT plus RAG is a student who didn't study for the exam, and they are both attending the open book exam. So we all know like a student who studied for the exam would have a better knowledge about the structure of the textbook. They have a better knowledge of how you can reference in the different materials and try to locate the knowledge and trying to see which part is most helpful in your textbook that helps you answer the question. So we'll show that these are the two key differences in RAFT between RAFT and the RAG technique currently. So the question about RAFT entire paper after we had the intuition of preparing for an exam is much better for not preparing for an exam. It's basically how do we prepare and how do we train or fine-tune a language model for an open book exam. So RAFT builds on this intuition and tries to answer this question. So now up to now, hopefully I delivered this intuition and also the the question we studied on the RAFT. And in the next couple of slides, I'll be presenting what is RAFT and how RAFT technique would help you benefit through the open book exam. So basically, basically the final goal final results we are having here is we can train a Llama 7B model, do much better than the even the GPT-4 model, which is state of the art at the time we published this paper on a specific domain exams. And so next I'll show how we do it. And then finally we'll present some of the results on how good RAFT is comparing to the other like RAG plus GPT or RAG plus Llama. So RAFT builds on a couple of RAFT is built on a very simple technique that can resolve two questions. The first question is when we actually attending the exam, when we are actually looking up one specific question in the textbook, there are lots of the distractor documentations. So for example, there might be two paragraphs that are presenting very similar knowledge, but only one paragraph is very helpful for answering my question. So we call the other paragraph that is not helpful for answering the question the distractor document or the distractor paragraph. So basically means it distracts my attention from the paragraph that can actually help me answer the question. So here, for example, we are having the language model or the bot on the right. And what we do is presenting him presenting it the distracted documentations and the Oracle documentations. The question I want to ask for this model is who actually invented the transformers? And I'll be presenting 4 papers in this case. So one paper colored green here is the paper Attention is All You Need. It's the original like transformer paper, and you can find the authors on the paper. That's helpful information you would have to answer the questions. And the rest of the 3 papers are irrelevant. They are Atom paper, Glove paper, and ResNet paper. So they are actually the papers in the AI domain that that is not very helpful for answering the question who invented the transformers. So what we want to teach the model in this behavior through the dataset preparation of the fine tuning is basically the model needs to learn only pay attention to the Attention is All You Need paper, given the question is who invented transformers, and ignore the irrelevant documentations like the Atom, Glove, and ResNet. So in this in this open book exam setting, it's basically we only giving you a textbook of let's see physics. We only pay attention to the paragraph or the specific chapter that is relevant to your question, and we ignore the other chapters and the other paragraphs because they are not helpful for answering your question. So that's the behavior we want to teach the model to be successful in an open book exam. And the second behavior we want to teach the model is basically this chain of thought reasoning answering style. So this style refers to once you locate the paragraph, once you locate the relevant part of the chapter, how do you do step-by-step derivation? How do you do step-by-step like chain of thought reasoning answering to actually arrive an answer of the question? So here, for example, we're having the specific structure of reason. We ask the model to provide the reason before providing the final answer. So this would be analogy to you have like step-by-step math derivation before, or the physics derivation before you actually reach the final answer. And another important thing we're asking the model to do is to quote from the original context. So this because this is a specialized technique for the model rather than taking analogy to the actual human taking the open book exam, because we know language model can hallucinate. For example, when you ask the model something that is unchecked, the model may get you the answer that is unchecked. Let me think of one example. Let's say, like I still ask the model where's the capital of California. The model may tell you it's San Francisco. So we call this a hallucination because this is a counterfactual. This is not something like presented in the daily life. This is not something presented, in a factual setting that you want the model to do. So the model would hallucinate a lot. It will even hallucinate like 1 + 1 = 3 in a very extreme case. That's one example I was having. So when we're introducing this quote behavior and verbatim citation of the original context, the model would say this specific documentation about the sentence, this specific documentation about, like, let's say the hotels here. When the model specifically generates this, it will reduce its hallucination. So in the physics example, if we are actually citing from Newton of the law of gravity, then we know that who invented the law of gravity is Newton, but not Einstein, for example. So this would greatly reduce the hallucination and improve the accuracy of the model. And combining these two, we can actually reach the final answer of this question. So RAFT is actually just the core concept of RAFT. It's just teaching the model these two behaviors I just mentioned. The first behavior is how we can teach the model to locate the most relevant information and ignore the most irrelevant information. And second behavior is how to teach the model to do the reasoning of the documentation, to do the quoting and the citation of the documentation without hallucination, and you can arrive the answer correctly. So this is also like very natural to how students and how students are taking the exams. You first want to find the most relevant part that is help you answer a question. And second, you will want to cite from them. You want to do the chain of thought reasoning, and then you can improve on your exam settings. So this is the two just very simple, raft a very simple technique about preparing dataset that helps your model trying to adopt these two behaviors. After the dataset preparation phase, we would do standard fine-tuning of the model, and I will show you a little bit later at the very end of the presentation how we can do that. That's basically a very standardized fine-tuning technique. And finally, at the inference time, we just adopt the standard RAG technique. That here we can say, oh, what is the attention used in Mistral? And we have the standard like RAG search or the retriever search pipeline and techniques. And then they will return me the Llama 2 paper, it will return me the Mistral 7B paper and the MPT 7B paper, etc. And we have a RAFT trained language model to synthesize answer and getting the most relevant documentations from most relevant paragraphs from documentation and answering a question. So the attention used in Mistral model is called sliding window attention. This is all very like a standard RAG technique. We adopted in the inference time. So that's it. Like, don't be very scary. RAFT is a very simple technique that we adopt in dataset preparation and training time, and that's inference. So entire 3 slides, I basically introduced how we do RAFT, and surprisingly, I'll show you some results later. This is really, really effective that we can enable a Llama 2 7B model to be as comparable as performable as a GPT-4 model in a specific domain. But in general, of course, GPT is a much, much better model. So, and on the next couple slides, I know we're actually very interested in one of the topic here, which is comparison of RAG, in-context learning, domain-specific fine-tuning, and RAFT. So I will do a couple of comparisons of the pros and cons of the different techniques, and then we'll dive into the results of RAFT. So people are often asked a question like, oh, we previously have the RAG technique. We also have the fine-tuning technique. Now you introduce me the RAFT technique. How we actually, under which scenario we want to use them. And in the next couple of slides, after we learn how the RAFT works, we want to actually do a sort of comparisons of the different techniques and see which one might be the most useful and relevant to your use case. So here is a RAG. RAG is basically retrieve and inserts external data into the context based on a query X. But query here, we mean like basically the questions or the user chatting history. So let's see, like the question is, what's the meaning of context window in language model? Typically, we would put this into a database, and the database contains a lot of, like, say, the papers of the language models. So the database would return you a bunch of documentations. Documentation 1 might be the 24, like the 24 papers about Sora, let's say. The document 2 is a context window, and document 3 might be the in-context learning with in the large language model domain, etc. So, and the inference time, you would take both the orange part and the purple part into the language model, and the language model would answer your question. The context window is what based on the purple part. So we have a couple of very advantage of this technique, which is it is very easy and it's cheap, and also it can sort of learn your um, it can sort of learn your document or you learn your domain. By domain here, I mean basically the documentation contained in database. So you don't have to do any fine tuning. The model just ideally the model just inherently worked. And but a cons is like we need to add some of the more context window because we're presenting the model with more context from the database. And we have the bad and irrelevant information added. So this would mean like when you have three documentations here, but only one of them is actually the one you need. This is usually a little bit confusing for the models to answer the question. And thirdly, it's not like a very reliable in a lot of the scenarios. So in-context learning is basically gives the model some of the example or templates to learn from. So here is a very good example. Let's say I want to get the latest reports on RMs from NVIDIA. And the model would say, like the human would construct a couple of examples. Let's say first I will use an internal search tool to search all the documentations or all the reports of the language models from NVIDIA. And second, I will just do a sorting. I'll locate the latest one from NVIDIA. And the language models would just follow this pattern of the examples and trying to do search first, and then trying to do the sorting afterwards. So the pros of this approach is actually it's also pretty cheap and easy, and it works, right? So basically, people would construct examples, and the language model would follow your examples. But the cons is like it's except for it's add a little bit of more context window. The examples require effort. So imagine if you're getting the latest reports from RMs of get the latest reports on RMs from NVIDIA. You have to first use the search tool, and then you will use the sorting tool. You need to construct specific example for this use case, but this use case may not be actually useful if you want to, let's say, answer the question from a mathematical domain. If you're actually answering question from a mathematical domain, you have to construct another sort template or another like examples that how you want the model to break down the steps of the mathematical reasoning and finally figure out the answer. In that case, you might want to first actually see what's if you're solving an equation of 1 plus 2 and times 3, you might need to first do the calculation of 2 times 3 and then use the results of 6 plus 1 equals to 7. So you can get the final results. So these examples are slightly very domain specific, and it requires extra effort to construct these examples for each of domain you're interested in. And finally, this is not finally, but before we introduce RAFT, is this like comparison of domain-specific fine-tuning, which is generally referred to fine-tuning. So fine-tuning would collect examples of conversations and train the language model to using the script. For example, you would collect this information, still like get me the latest reports on RMs from NVIDIA. And the chat history would be first, I'll use internal tools like search internal. And you have more couple of examples like this. And then let's say you collect 100,000 of these examples. You perform a fine-tuning stage of the language model using this conversation examples. And afterwards, let's say you're still asking the same question and the model would give you the answers. You can actually ask different questions, like let's say reports from Meta or Google, and then the model would still want to search internal on Google database. So this is the time of the inference. Fine-tuning, there's no extra context, and also it will make the model very reliable on answering this type of questions. That's the fine-tuning's benefit. But the cons is like it's actually expensive to train. And once you train the model, you are having a hard time to refresh its knowledge and update the model, which is typically the case if you want to update some information in your documentation or if you want to update some information of your RMs. It's slightly hard to do because you actually need to construct another fine-tuning strategy. And this basically means language model memorize your domain. The language model would memorize the training data you would give it. So in order to refresh this knowledge, you need to construct another training set. So how RAFT is a pretty clever and a brilliant idea in our mind. It's basically RAFT combines this RAG and fine-tuning. So the RAFT wouldn't want to teach the model to memorize the knowledge, or RAFT wouldn't teach the model to memorize the information you provided in the training data set, but rather RAFT teaches the model the behavior of how you can locate important information from the context and how you can reasoning and citing from the original context to answer the question. So this is sort of this teaching the model the behavior versus teaching the model to memorize the knowledge. And we can see here, this is RAG and fine-tuning. I'm slightly ignoring the in context here because that's another technique that can apply on top of all these three methods. But we have the summarization of the pros and cons here in the RAG and fine-tuning. And RAFT is actually, except for it adds a little bit more context window, it's actually very combine the benefit of the both, which is there's easy and cheap, it's reliable, and you can refresh. You can refresh the model because the model now only learns the behavior of referring to the documentation rather than memorizing the knowledge. So we can see that it's easy and cheap because we can use a 7B Llama model to get comparable performance of GPT-4. And it's reliable and we can refresh it because once I update the documentation, I present this to the RAFT model. The RAFT model would know to read from the newly updated information and answer my question. So here's a comparison of the three techniques. I think in short, which I would mention in the very beginning of the slides, is if you're doing RAG, I think you should do RAFT because of the benefit we mentioned above. So now let me briefly talk about how good is RAFT and how can we use it. So here we adopt a benchmark of the Gorilla API benchmark, which is how we can actually use different models from Hugging Face, whether I should use the BERT model, or I should use the GPT model, or I should use the Stable Diffusion model, depending on my context. Let's say I was asking a question, generate a cat image. Then the model, in this case, I want the model to answer me, use the Stable Diffusion API. So on the blue bar here, we have the open book exam, but we don't study. This is the Llama 2 model plus RAG. This is a naive RAG like instruct version. And we just present the question and also the context here. So we can see the model is doing pretty bad. And it's having like roughly 10% on the Hugging Face and 20% on TensorFlow Hub. So here is RAFT. After fine-tuning for this specific domain, of course, it's like also slightly only working in this in-domain examples. But if that's all the examples, that's, for example, like Hugging Face API documentations is all the documentation that you care about, this is the performance you can get. It's really good. So the RAFT actually can actually have over 60%, almost like 5x improvement on the Llama 2 model. We're using the same model here, which is 7 billion, and the 5x improvement in this specific domain. And here is the fine-tuning technology. We teach the model to memorize the information, to memorize the knowledge. So it's also improved by a good margin, but the RAFT is actually much better than this domain. Finally, there's a very interesting comparison we conducted, which is how if you're a very clever, very clever student like GPT-4, if you don't study, if you don't train on your domain, how you can actually get better. Like what's your performance? So you can see that this proves our intuition. If the model is, if the student studied, it's much better, more preferable in the exam settings compared to a student that don't study, that doesn't study. Even though the student that doesn't study is much more clever, let's say it's a much more stronger model. And a couple more results we are having here is very similar to the previous results. Is we also conducted on the PubMed, which is the medical documentation domain, and the Hotpot QA, which is a Wikipedia question answering domain. We can see that using RAFT model, we can get very close to GPT 3.5 plus RAG performance across all of these tasks, and sometimes it's much better. And DSF here is domain-specific fine-tuning, which is a fine-tuning technique we're having on the paper. So this concludes our results, and this RAFT work has been stably used in the industry as well. We have a joint blog post with Microsoft and Meta. This is my Twitter on twittering this, and there are lots of people like this. And here is a Microsoft AI blog, and the first one to the left is RAFT, which is a monkey taking open book exams. And this has been far the most viewed blog in the Microsoft AI blog. And we are having the GitHub here. Sorry, the GitHub might be a little bit blocking. But we have another link afterwards. So this is how the RAFT technique are. And I'll take very quick slides on how we can use RAFT, and I'll be taking questions afterwards. So how we can use RAFT is really simple. The key of the concept is doing the dataset preparation, that we prepare a RAFT training dataset to fine-tune the language model to do that. So here is a link of the reference we can use. It's also merged, or it's not so merged into the Gorilla repo. But the key concept here is how we can actually ask a GPT to generate question answer pairs regarding to your documentation. And this would help the model to help to train the model have the behavior of localizing the information and also trying to construct chain of thought answering styles. I would very encourage to take a look at this repo. It's very easy to use. And the second step is just fine-tuning. By fine-tuning, we have either if you have GPUs, we have the next slides of providing the fine-tuning script here, or you can also use Microsoft AI Studio if you don't want to train this on your own GPUs. And here is like the Llama recipe here, which they also adopt RAFT. They can also do the fine-tuning on your own GPUs using this and the RAFT prepared dataset. And all these slides will be shared with you, so no worries. You can take a look afterwards. And I think that concludes all my talk about RAFT, which we want to actually adapt language model to open book exams and RAG in this setting. So I think there are a couple of questions here I see. So Jim asks, how does RAFT or RAG compare to simply using Google's new 1 million token language model architecture and throwing your customized data into the context and then asking questions? So this answer line. So this would be very interesting question to ask, but there are like a couple of from two aspects we can compare. One is if you're having the 1 million context window, it doesn't mean necessarily your model is understanding and can accurately localizing the information in this 1 million context. There's a paper called Lost in the Middle, which says your language model may be very confused and maybe not able to utilize the fully of the context window. So by still, even if you have 1 million token language model architecture, using the RAFT technique, you can actually also teach the model to better localizing the information, even though you can actually put all of them. And the model would do much better in this setting. And secondly, is of course the cost. Like if you have the if you want to put 1 million or the entire physics book into the language model, the token would be 1 million. But if you can actually do the RAG technique and using the RAFT, your token would be reduced to a couple of paragraphs from this 1 million context of textbooks. And this would conclude the two aspects. So also Thomas asks, what is the data privacy issue? Like I don't own my data to pass it to language model, which may be owned by third party or public. So the data privacy issue is that I think it's resolved by RAFT, because RAFT is a concept how you can train your own language model to have your own data to analyze or to treat your own data. So you don't have to actually pass the data or pass your personal data information into the GPT, which is a public, like a private model. But you can actually train your own model only on your personal information or only on your enterprise documentation. And you hold this data. You would make sure every of the data privacy, every of the data flowed into the language model is controlled by you and is only used by you. It won't be accessible by anyone else in the world. Mara asks, please post the links and URLs and GitHub to the paper to the chat for the chat paste. I think we'll be sharing all the slides and to you guys afterwards. And someone, I think Vinay also asks how much human labeling is required in the preparation of the dataset for RAFT. So we don't do a lot of human labeling because we simply prompt the language model to generate those conversation like question answer pairs. And that's usually works fine for us on across all the domains, like including medical domain, including a lot of like Wikipedia domain and API documentation domain. And Tripasi also asks, is the process of ignoring the distractor documentation similar to improving the retriever of in RAG or attaching importance scores? Yeah, these are orthogonal methods. So even though you would want to improve the retriever of the RAG or attach importance scores, you still want your model to be more reliable and more amenable to these documentations. So I think this could be combined and get to the best results by combining the RAG technique and also the RAFT technique. Because RAFT is simply just a fine-tuning technique to fine-tune your model, where RAG is a separate technique that you can improve your accuracy on the retrieving the documentations. Yeah, I think I'm actually out of time here. I'll be very happy to